AI agents in robotics. AI agents are playing a transformative role in the field of robotics, where autonomous systems and adaptive learning are crucial for performing complex tasks in dynamic environments. Robotic systems equipped with AI agents can now sense, interpret, and act upon their surroundings, allowing them to function without human intervention. The integration of AI agents in robotics has enabled advances in various domains, from industrial automation to healthcare, agriculture, and autonomous vehicles. These systems not only enhance productivity, but also offer solutions to tasks that are hazardous or time-consuming for humans. AI agents in autonomous systems. Autonomous systems represent one of the most exciting applications of AI agents in robotics. These systems, such as self-driving cars, drones, and automated delivery robots, operate in unpredictable environments and rely on AI agents to make decisions in real time. AI agents in autonomous systems are tasked with perceiving their surroundings, analyzing data from multiple sensors, and deciding on the optimal course of action to accomplish their objectives. For instance, self-driving cars must process a vast array of sensory inputs, such as camera feeds, LiDAR data, GPS signals, and radar, to navigate safely through traffic. The AI agent in the car makes decisions on speed, route, obstacle avoidance, and more, based on the current environment and predictive models of possible future states. Drones, similarly, use AI agents to fly autonomously, carrying out tasks like mapping large areas or delivering packages to hard-to-reach locations. One of the challenges in autonomous systems is the need for robustness in uncertain conditions. AI agents must be able to operate safely and efficiently in environments where they encounter unexpected obstacles or changing conditions, such as inclement weather or evolving road patterns. Through advanced algorithms and deep learning, AI agents in autonomous systems continue to improve, making transportation, logistics, and exploration safer and more efficient. Robotic Process Automation (RPA). While autonomous systems focus on physical robots, robotic process automation (RPA) involves the use of software agents to automate repetitive, rule-based tasks that are typically performed by humans. RPA is widely used in industries like finance, healthcare, and customer service, where AI agents can process large amounts of data and execute tasks such as form filling, invoice processing, and customer record management. AI agents in RPA are designed to interact with existing software systems in much the same way as a human would, logging into applications, performing transactions, extracting data, and generating reports. What sets modern RPA systems apart is their ability to incorporate AI and machine learning to handle unstructured data, such as interpreting emails, reading scanned documents, or processing spoken commands. For example, in the banking sector, RPA agents can be deployed to process loan applications. By automating repetitive tasks like data entry and document verification, these agents reduce the time required for loan approval and minimize human error. In healthcare, RPA agents can manage patient records and schedule appointments, freeing up human staff for more complex tasks. Though RPA is often associated with repetitive back-office tasks, the inclusion of AI has allowed these agents to tackle more sophisticated workflows that involve decision-making and adaptive learning. This advancement is making RPA more applicable in fields requiring higher cognitive functions, such as compliance and risk management. Self-learning robots and adaptation. Self-learning robots represent the pinnacle of AI integration in robotics. These robots are equipped with learning agents that allow them to improve their performance through experience, much like how humans learn from trial and error. Self-learning robots leverage reinforcement learning, where they interact with their environment, perform tasks, and receive feedback in the form of rewards or penalties. Over time, they optimize their behavior to maximize positive outcomes. One prominent application of self-learning robots is in manufacturing. In complex, automated factories, robots equipped with AI agents can learn to handle new materials, adapt to changing production lines, and even predict when maintenance is required. By continuously learning from their environment, these robots reduce downtime, increase efficiency, and minimize the need for human intervention in routine tasks. In addition to manufacturing, self-learning robots are being used in agriculture, where they autonomously tend crops, identify pests, and adjust irrigation patterns based on real-time environmental data. These robots help farmers optimize crop yields while reducing the need for manual labor. The challenge with self learning robots lies in creating systems that can generalize from their learning and apply it to new, unseen situations. As deep learning models continue to improve, the ability of robots to transfer knowledge across tasks and environments will also grow, leading to more flexible and intelligent systems capable of handling diverse real world challenges. The integration of AI agents into robotics, whether in autonomous systems, RPA, or self learning robots, is revolutionizing industries by enhancing efficiency, accuracy, and scalability. As AI continues to evolve, the capabilities of robotic systems will expand, leading to even more advanced and adaptive machines that can operate in increasingly complex environments. The future of AI and robotics holds immense potential, from fully autonomous industrial plants to intelligent drones that can explore other planets.